Hello students, hope you all are doing good. Now we are going to continue the topic magnetic effects of electric current, grade 10 physics part. That is part B, magnetic field due to circular loop, solenoid and electromagnet. In this topic we are going to continue and discuss about magnetic field due to circular loop, solenoid and electromagnet. So we'll begin with what do you mean by or what is meant by magnetic field due to a current carrying circular loop. So when an electric current flows through a circular loop, a magnetic field is produced around it. In the last class, the Sir Oersted has given us the idea that by the help of electric current, magnetism is produced. So now here we have a loop which is in the shape of a circle. That's why we have called it as a circular loop. So when current is flowing through a loop, a magnetic field is produced around it, a right hand thumb rule. You can check it. Magnetic field lines of magnetic field produced by a current carrying circular loop. So observation, what did you observe? Magnetic field lines are circular near the wire. So what is the shape of the magnetic field lines? They are circular in shape, and where they are present, they are formed at the near the wire, and at the center of the loop, students, the field lines become almost parallel, indicating a stronger magnetic field. Please note, at the center of the loop, the field lines will become almost parallel, which indicates there is a stronger magnetic field. So what will be the direction of magnetic field? To understand the direction of magnetic field, we will take the help of clock phase rule. So imagine the circular loop as the phase of a clock. It is in the phase of a clock. Current is moving in the clockwise. So the direction of the current is this phase of a circular wire is clockwise. So the phase of circular wire carrying current will act as a south magnetic pole. If the direction of the current in the circular wire is clockwise, then the phase of the circular wire which is carrying the current, will act as a south magnetic pole. If the current flows clockwise, the phase behaves like a south pole, what we have discussed. If the current flows anti-clockwise, sir, then what will happen? Vice versa, reverse, the phase will behave like a north pole. Always remember, this rule will help you determine the magnetic polarity of the circular loop. This rule will help you determine the magnetic polarity of the circular loop. So how do you find out the strength of the magnetic field in a circular loop? The magnetic field at the center of the loop depends on will depend on how is the magnitude flowing through, magnitude of what? Magnitude of current which is flowing through the conductor. The magnitude of current flowing through the conductor, and how many number of turns are present in the coil, and how much is the radius of the circular loop. It depends upon the radius of the circular loop, the number of turns, and the magnitude of the current flowing, where it is flowing through the conductor. Important points to remember here: more current, stronger magnetic field; more turns, stronger magnetic field; smaller radius, stronger magnetic field. Okay. Next comes magnetic field due to a solenoid. So what is a solenoid? It is a long cylindrical coil. What is a solenoid? It is a long cylindrical coil which consists of many closely wound circular turns. So what it consists of? Many closely wound circular turns of what? Of insulated copper wire. See, number of turns of insulated copper wire, and this black color one is the coil. So when electric current is passing through the solenoid, it will produce magnetic field similar to that of a bar magnet. When electric current is flowing through the solenoid, what happens? It will produce a magnetic field similar to that of bar magnet. Characteristics: one end behaves as the north pole, the other end behaves as the south pole. The magnetic field inside the solenoid is stronger and nearly uniform. So what are the characteristics here we are going to observe? One end will behave as a south pole, and the opposite one, that is the other end, will behave as a south pole. One end, is the north pole. The opposite, the other end will behave as a south pole. The magnetic field inside the solenoid is strong and nearly uniform. Inside the solenoid, the magnetic field is strong. Next comes electromagnet. An electromagnet is a temporary magnet which is produced by passing electric current again. Through where you are passing the electric current? Through the solenoid wound around a soft iron core. Till you are passing the current, it will behave as an electromagnet. When you are not passing, it will not behave as an electromagnet. The properties, it will act as a magnet only when the current is flowing, students. If you want to increase the strength, you need to increase the current, or you want to increase the number of the turns, or by using a soft iron core. So these are the ways by which you can increase the strength of an electromagnet. Sir, why do I study and what are the uses here? Electromagnets are used in electric bulbs, electric relays, cranes for lift and scrap iron, loudspeakers, electric motors, magnetic door locks. These are the different uses in our daily life of electromagnet. So difference between a bar magnet and an electromagnet. Bar magnet, which is a permanent magnet. Electromagnet is a temporary magnet. Strength is fixed in bar magnet. Strength can be varied in electromagnet. Cannot be switched off. Bar magnet can be switched on and off. That is your electromagnet. No electric current is needed for bar magnet. But for electromagnet, it requires electric current. It requires electric current. Any further queries, any students, any doubt, you can use the WhatsApp number or you can use the comment section to clarify your doubts, students. This come to an end of part B. Soon we will upload part C also. Thank you, students. Take care. Be safe. Bye-bye.